Hey there, and we're going to start with our new topic, the probability density function. This introduction is split into three sections. The firstly, looking at what it actually is. The second video, looking at its properties and how to recognize one of these functions. And the third video on some questions. Right, let's start right off with making you do some work. So, here is a binomial function, and I have worked out the chance of getting 0 in this function, and that is 0.22. I've plotted it on this graph. So there's x, the probability of getting x. What we need to do is figure out the chance of getting a 1, a 2, and a 3, and plotting it onto this graph. So pause the video and do that now. And unpause, and you should find that the chance of getting a 1 is 0.43. So with a ruler, which I don't have, so in which case I'll freehand up to there, very convincing straight line. Getting 2 is 0.29, which is there, and getting 3 is 0.06. which is a little one, it's very, very small, down there. So, my first question is, these are all kind of rounded values, what would all the lines on this graph add up to? So what would all the lines on this graph add up to? Now, since it's probability, they should all add up to one whole. Okay, then here's your next thought. Why are there gaps between these bars? Pause it and have a think and try and answer, why are there gaps between the bars on this distribution? So hopefully you thought about it, and still thinking, because you haven't. Okay, and the point is that in the binomial, you can only take integer values. Okay, it's all for discrete. It's a type of discrete random variable, because our variables can only take whole numbers, our integers. With the probability density function, this looks at continuous random variables. So in fact, we're looking at graphs where rather than having straight lines, the probability is going to be shown by the area under the graph. And if you think about your core maths, the area under the graphs is found by some beautiful integration. So that will be coming up later on. In this case, that. So let's define a continuous random variable. So with these, they can take any value in the given range. So any value at all between 0 and 3, for example. It could be 2.5, 2.7, 2.8, 2.3267443, anything like that. And typically, these conclude things like rainfall, i.e. the chance of getting, say, 20 centimeters of rain in a month. It can be height, how tall someone is, what's the chance you're going to be 2.5 meters tall, the mass of something, all those sort of things. These continuous measurements are represented by these sort of variables. And the graph of these look like this. Okay, so it's got a graph. Hi, pens. Here's the values of x between 0. So in this one, our value of x could be between 0 and 4. This is some function of x. And your probability is the area underneath. In fact, probability density functions, to be honest, are like histograms, where the area represents the data or the probability in this case, not the height. So in our earlier graph, the probability was the height. Now, for a continuous random variable, using a probability density function, which is this bit here, is a graph. So this is, like in a histogram, you have an axis here is your frequency density. Here is a probability density. And that's shown by f of x, some function of x. Okay, you've seen something like this before. You've seen this before. We're looking at your normal distribution. Your normal distribution was shown by the area under the graph. It's continuous. This is another version of the same issue. Okay, so the thing of the continuous distribution is it's very, very unlikely to have an exact value. So if I say to you, what's the chance of 0.0002176 millimeters of rain, and exactly that number is probably going to be 0. Okay, what's the chance of having exactly 2 centimeters of rain? Again, the chance is exactly that, not an atom more, an atom less. Just think about how unlikely it is to have exactly that measurement, to the smallest possible degree. Okay, so in a continuous random variable, the chance of getting any exact value is going to be 0. So the last thing to look at for this video is our properties. So this says your probabilities will not be negative for all real numbers. Real numbers is anything on your number line. So your probabilities are not negative, which makes sense. You can't have a negative chance of things happening. So your graph will always be above your x-axis. And then we're told that when you integrate the function, then we integrate between infinity and minus infinity, i.e. everything, you get an answer of 1. So the area under the whole graph, under the curve or whatever shape it is always going to be 1. These are facts you need to know for the next bit.